Hi guys, so this is just a little intro to the segment addition postulate. You hear that big word, maybe think, oh my gosh, what are we talking about? But just think of this as part plus part equals whole. You've kind of done these before, but you may not have realized the very formal name of segment addition postulate. So that's what we have to think about. As we go forward with the vocabulary, you notice that we have things like vertical angles and linear pair and arrays and angles and planes, but then we have things like perpendicular bisector theorem, which tells us certain things, or the segment addition postulate, which tells us if 3 points A, B, and C are collinear in the same line, and B is between A and C, then AB plus BC equals AC. That makes sense. A part plus a part equals a whole. So let's just do 3 quick examples. Okay. The length from point A to point B is 15. The length from point A to point C is 32, and A, B, and C are collinear. So let's do a visual representation of that. A to B is 15. And then A to C, so extending that, the whole thing is 32. And it wants you to find the length from point B to point C. Now, some of you already know you're supposed to do 32 minus 15 and get an answer. I'm just going to put a little X here as a representation of BC, and I'm going to do my setup algebraically. Part plus part equals whole. And then I'm going to do the same thing that I do here. And I'm going to get the same answer you did, which is X equals 17. Now, I bet you know what I'm going to ask you next. Did you answer the question? Because it said, what is the length from point B to point C? Turns out that what I labeled X was also the label of BC. So we can say that BC equals 17 and we get our answer. Okay. So that is your part plus part equals whole. Let's look at this next one. The length from point A to point B is represented by the expression 4x plus 10. So I'm going to draw that. I'm going to call this A, call this B. I'm going to do 4x plus 10. The length from point B to point C is represented by 6x minus 8. So I'm going to draw that. Now, if B is in the middle of line AC, hey, didn't we just learn something about middle points? So a middle point, right, or the midpoint of line AC. What is the length of AC? Well, it didn't tell me what AC equals, and yet it's asking me what is its length. But what do we know when B is the midpoint? It's almost like it's the point where something gets bisected, which means this side of the line is the same as this side of the line. So again, we do our setup, or we do 4x plus 10 equals 6x minus 8. We talked about in the first week of school that Miss Kulkarni, her preference is to keep the x's positive, so she usually brings the smaller of the two over. It doesn't matter if you subtract 6x or subtract 4x. I just choose to keep my line bigger. So I get 2x equals 18, and I get x equals 9. Now, have I answered the question, ladies and gentlemen? I don't think I've answered the question, because the question was, what is the length of AC? It was not, what is the value of x? It said, what is the length of AC? So it wants this whole value right here from A to C. And we got to plug x back in, don't we? So we get x equals 9. So 4 times 9 plus 10, that's 36 plus 10, and that's going to give me 46. Now, what should we get for this side? Shouldn't we also get 46 because it was the midpoint? So 6 times 9, which is 54, and 54 minus 8 is also 46. So we did get the same on both sides. So that tells me my value of x is correct. It checked out because it should give me the same value on both sides. Still haven't answered the question, though. It asked me what the answer for AC is. So I'm going to do 46 plus 46, and I'm going to get 92. And now I have my answer as to what the value is. So part plus part equals whole is the segment addition postulate. The definition of a midpoint is that it's the middle. So the parts on one side equals the parts on the other side. So in this particular equation, I had to know to set them equal to each other because B was the middle. So 4x plus 10 and 6x minus 8 have to be the same. And then the segment addition postulate tells me to do part plus part equals whole. So that combined two concepts in one problem. Let's do one more. The length from A to B is represented by the expression x squared minus x. So I'm going to draw that, x squared minus x. The length from point, I think if that meant to say point B to point C, it looks like I have a little typo here. Point B to point C is negative 3x plus 14. And then if the length of AC is 10, so the whole thing is 10, what is the length of AB? You know, every year I do this problem and every year I tell myself, let's make this BC because it's more fun to do. And every year I forget to change that. So, oh my goodness. All right. So I have my setup. I have a part, a whole. So let's do it. X squared minus x plus negative 3x plus 14 equals 10. Now, we have x squared minus 4x plus 14 equals 10. Oh my goodness gracious, ladies and gentlemen. We talked about this very fleetingly in the first week where we talked about when we have quadratics. Now, you may or may not have covered this extensively in Algebra 1. So remember, with quadratics, when we are trying to solve, we get everything over to the left-hand side in what's called standard form. Standard form means you order things from the highest exponent to the lowest exponent. Okay, and now we look to factor. And do you remember those lovely little things you used to factor? One of the things that you were probably asked by your teacher, give me two numbers that when I multiply them, I get positive 4, but when I add them, I get negative 4. So when I multiply, I get positive 4. When I add them, I get negative 4. And that you probably got was negative 2 and negative 2. Now, this is called the factoring process. I haven't solved it yet. So to solve it, I need to set my factor equal to 0. And I don't need to set both of them because they're the same thing. So I know the answer is going to be x equals 2. Did I answer the question yet? Remember, I modified it to what is BC. So BC is the same thing as negative 3 times 2 plus 14. In other words, negative 6 plus 14. So BC equals 8. And you know how you can check your work? You could plug this x back into AB. 2 squared minus 4, or excuse me, 2 squared minus 2. That's 4 minus 2. That gives me 2. So I got 2 here, and I got 8 here. Adding them together give me 10? Yeah. So that lets me check my work. Now, remember I've told you in class that a lot of times we will try to cover some algebra concepts that you either skimmed at last year or maybe didn't even cover at all, depending on what your teacher and what your school did with the end of your curriculum. So I want to be clear that when we're doing this geometry right now, the assessment limit is part plus part equals whole. The assessment limit is, can you set this up? So in our class, when you take a test or a quiz, you will not be required to factor to find the answer. Not yet anyway, not until we do a few more of these type problems, okay? But right now, part plus part equals whole, and then being able to solve for x to the first power, you'll be able to do that. But we will not deal with quadratics just yet. Hopefully you understood that and you can do your Delta Math homework. If you were in the 8A class, you got a little less time to do this because of our day off from school. So just try to make use of flex time if you need to. Okay, have a good one.